So good morning. Let us start with the today's session. Today we will be starting with a new topic, design of IC engine. Now, before me going forward, let us keep this session interactive. The question to you is, what do you mean by IC engine?
The engine where is the fuel and air ratio come and it will be ignited inside. So it is called the
Uh,
IC engine, internal combustion engine.
okay, good. So the main point which I take it from your definition is the ignition or the things, the combustion take place internally. That was the last thing which you pointed out, and that was the main thing which I will extract from your answer, that the combustion take place inside the engine only. That's why its name is internal combustion engine. Now, let us go towards the revision of various processes which you have learned regarding thermal nature, because here we are dealing with the heat part. So there should be some thermal concepts also into the picture. So again, I want your intervention and ask you, what are the different types of process you have learned?
Compression process, expansion process,
Okay, good.
constant pressure process.
Yes. Constant pressure.
Isobaric, adiabatic, isothermal.
Correct.
Isotonic,
So okay,
isobaric,
let me just
isothermal.
write down here. Then we will discuss on it. So first, what I could hear from your side is isobaric. Okay, so I will write it here, isobaric. And then second one,
Isochoric,
okay,
isothermal,
isothermal. Any more?
Adiabatic.
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 Okay.
Polytropic.
Okay, polytropic. Okay, so now let us go and discuss one by one, and let us see how much you know about this processes. It's just a refresher which we'll be using in this topic. So let me first highlight the thing which I want to discuss is this one. What do you understand by this term, adiabatic process?
No
Adiabatic
heat transfer,
process.
no mass transfer.
No heat transfer, no mass transfer. Perfect answer. So I will write here, in adiabatic process, the heat transfer is zero, that is Q is equal to zero. Am I correct?
Yes, sir.
Okay. Okay. If there is no heat transfer, okay, just again a logical question. If there is no heat transfer, what can you tell about temperature? Whether it will rise, it will fall, or it will be constant?
Constant.
Okay. Any other expectations? One of them is telling constant.
As there is no heat transfer, temperature will remain constant.
Okay. That's your concept, that you are telling it is constant. Okay. Someone also said constant. Now I want to again clarify this. If Q is equal to zero, what does it mean? Q is equal to zero means there is no heat transfer. Okay, again, emphasize on the word. Q is equal to zero means there is no heat transfer. There is no transfer of heat. But I never told that heat is not generated. I told that, or you only told that heat is not generated.
Sir,
Yes or no?
wall के आसपास transfer नहीं होएगा, अंदर generate होएगा.
No. It's a adiabatic process. If you are telling me it's a adiabatic process, that means that itself means that there is no heat transfer. Okay, heat transfer is not there. For example, let us discuss that. Let us say this is the arrangement of piston cylinder, and this is a closed valve. This valve is closed now. Okay, nothing can go out, but there is a fuel inside or some liquid inside. Okay, now if I compress this fluid or compress this air, first of all, this valve is closed, so it cannot go out. That means heat cannot go out. Again, I repeat, because of it is a adiabatic process, the heat will not transfer from this cylinder to outside surrounding. इसमें किसी को doubt है क्या? Because it is an adiabatic process, the heat will not transfer from out to in or in to out. इसमें किसी को doubt?
No, sir.
No. Now, if I compress this air or whatever it is there inside, because of the compression, will not there be heat generation here in this part? Heat generate होगा कि नहीं?
होगा ना sir.
होगा.
Compression की वजह से.
So because you are compressing something, you are increasing the temperature. So if you are increasing the temperature, how can you say that temperature is constant? Now you understood the logic?
Yes sir, मैं गलत था.
Okay. So that's the only point. That's the only point which I want to prove is just seeing the PPT and putting all the things on the slide does not work. When we discuss, we come to know the different things which we are lacking about. So I hope now you will not make a mistake henceforth, that if I tell you that it is an adiabatic process, you will just say the transfer of heat is zero, not the temperature rises zero. So adiabatic process is also known as what? Have you heard something like this? Yes, good. Isentropic. So adiabatic process is also known as isentropic process. Basically, there are 5 different words. If I go into the details, there are 5 different words which describe this process. The first one is adiabatic. Second word is reversible adiabatic. It is also known as frictionless process. It is also known as constant entropy process, or it is also known as isentropic process. But normally we use these 2 words interchangeably: adiabatic process and isentropic process. So, okay, so I will in our discussions also in the later stages, I will be using the words like adiabatic process and isentropic process only, but there are other words also which describe the same process. Okay, let us see any second one. Let us discuss about this now. So next one which I want to discuss is this one: isochoric process. What does it mean? It's just a refresher which we'll be using in our calculation part. What do you mean by this? Isochoric.
Constant volume process.
Constant volume. Perfect answer. Perfect answer.
Yes,
The
sir.
volume remains constant. So I will write volume is equal to constant. So that is known as isochoric process. Okay. Then let us discuss about this one. Isobaric. It's very simple. It's up from the name only. What can you tell?
Pressure.
Pressure will be
Pressure.
constant because it is isobar. Baric means it's a unit of pressure. So simply I will write pressure is equal to constant. So one of them, the first one is pressure constant. Isochoric means volume constant. So again, similarly, isothermal only you can judge what it can be.
It's called constant temperature.
Constant temperature. Okay, so this will be constant. Temperature is equal to constant. So I hope this all has refreshed your memories of our thermodynamics also.
Yes,
So
sir.
let us now move forward towards our part which we will be using: internal combustion engine. So here it is a clip of internal combustion engine wherein you can see the various parts of internal combustion engine. So basically this is the main part in the center. So this is known as a cylinder. Here it is written kahin to hoga combustion chamber in which the combustion take place. And as we discussed, it's an internal combustion engine. So this part is a major part of the process which we have to design: internal combustion engine. So again, you can, it's a self-readable diagram. So this is a camshaft, cam, mixture in, that means the flow of petrol or the gasoline or air comes in from here. It goes into the combustion chamber. The process goes on, and then again it leaves the system to this exhaust valve which is shown on the right hand side. The various things are cooling water, piston, crankcase, etc. And now here just see the quantum of things you will be designing in this topic. Just it is an overview of all the components which you will be designing in IC engine topic. That's why it is a 20 marks question. Design an IC engine, because it's an exhaustive list of which of the components which you have to design. Okay, so we will see it later.
क्या बनाना होता है सर?
क्या क्या
क्या
बनाना
डिजाइन करना
होता
होता है
है?
सर?
जो
सब कुछ मतलब
जो आपके सामने लिखा है सब कुछ.
सब कुछ.
Yes, whatever you are seeing in the diagram, all the things you have to design. That's why it's a question of 20 marks. Now let us discuss on this. Again, this we have already seen in your previous semesters. Just a quick refresher. What can you tell about this? What is this?
Process. Combustion process.
Combustion process. Okay. So can someone you explain this in short? What is actually I want to say from this diagram?
One complete combustion is take place in 4 cycle.
Okay.
4 stroke.
4 stroke. What do you mean by 4 stroke?
Ignition and expansion.
No, what
means,
do you, that are the components of the strokes. What do you mean by the stroke? What do you mean by a stroke?
सर वो piston का motion चार.
Yes, correct. The motion of the piston. Okay, let us say the piston is somewhere here at initial position. This is the initial position of the piston. So first piston will move from top to bottom. From bottom to top. I am just giving a generalized example. So from bottom to top. So this will become the first stroke of the engine. Okay. Then again it will travel from top to bottom. So this will become the second stroke. Then again from bottom it will go to top, and from top again it will come to bottom. So these are nothing but the strokes, that is the travel of the piston from the initial point to the final point in one complete cycle. Got it?
Yes.
Yes, sir.
Okay. So, okay, now, so again, the question goes to you only.
Sir, first of all, air fuel mixture is the intake going inside with the
Correct.
help of one intake valve.
Okay,
Then
good,
it
good.
closes. Then
Okay,
compression will be happen. Then
okay.
internal energy, that is the temperature, will be rises, and there will be some reactions. And
Okay.
after that, power stroke will be happen,
Hmm.
and the piston will go down, and
Hmm.
then exhaust valve will be open,
Hmm.
and the फिर से वो cycle फिर से repeat होएगी.
Perfect, perfect. Good answer. Very good answer. Okay, so the same thing I will also repeat in some more technical terms. The thing which you explained were exactly the correct ones. So the let us say the first cycle start with this air fuel mixture. Okay. So in this case, again, there is very logical questions and it can be a part of your technical questions like MCQs. In this part, in this first stage, what can you tell about the position of valves of inlet and outlet?
Inlet will be open, outlet
Inlet
will
will
be
open and outlet.
Yes, inlet will be open and outlet will be closed in the first cycle or first stroke, not first cycle, sorry, first stroke. The inlet valve will be open and exhaust valve will be closed. So here you can see air fuel mixture is coming into the cylinder, and because it is coming into the cylinder, it will push the cylinder down. So that's why it is written here. The first stroke is known as the intake stroke, in which air fuel mixture is drawn in. Just it will take in. Then when this crank rotates again, okay, there will be one more question on this rotation of crank later. So when this crank rotates again, this piston will try to go up. So in this case, what should be the position of valves? Ah, shit.
Both are closed.
The answer is already written on the screen. Sorry. The valves are
Yes.
closed. Okay, I should not ask this question because it was already written. So exhaust valve will be closed because we want to compress the things so nothing should leave out of the system. So what I will do is I will close both the valves. So now what will happen in this stroke? There will be a compression of the air fuel mixture which is inside it. So that's why the name of the stroke is known as a compression stroke. Now, once it is compressed, the piston has reached to its top dead center, TDC. Now, when it is fully compressed, all the gases are fully compressed. What we do is by using the time valve, we just ignite or give a spark at this place through a spark plug. Again, you can see the position of both the walls are closed because everything has to be inside, happened in the inside of the cylinder. Nothing should go out, nothing should come in. So because of this spark, again the gas will ignite and the work will be done and it will push the piston down, and that's why this is known as a power stroke. This is the stroke which is we are using in our automobiles. In power stroke only the power is used. The other intake, compression and exhaust, we have to supply power. Only in this stage we can consume power. Okay, so this is the third stage, and then again when cam rotates, it will push the piston up. Now you can see that inlet valve is closed and exhaust valve is open, so that all the exhaust gas comes out from the outlet valve. So this is the complete cycle of 4-stroke petrol engine, you can say, or any engine, a 4-stroke cycle. So intake, compression, power and exhaust. Now I told you that I will be asking you one question regarding the crank rotation. What can you tell about rotation of crank? What angle it should make?
90
90.
per stroke.
90 per stroke. Okay. 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 I will tell that your answer is wrong. Again, you just observe the figure and tell me what will be the angle subtended by the crank in one stroke. In one stroke.
180.
180. Correct answer. What is the basis of that?
सर वो जब पिस्टन नीचे से ऊपर जाता है तो वो
Hmm.
ऑलमोस्ट हाफ सर्कल कवर करता है,
Hmm.
एंड जब वो डाउन आता है तो वो हाफ सर्कल, तो हाफ सर्कल का 180 एंगल होता है.
Correct. Okay, so if I explain it in the other terms, let us assume that this crank which I have shown in this tilted position, it is actually here. Okay, this crank is here. So if this crank is here at the exactly at the 0 angle, if I consider this as my reference, this as 0 angle, if I consider the perfect vertical one, so where will be the position of the piston? Below or top?
Below.
Just see the diagram. First diagram.
Completely below.
It will be exactly below. That means at the bottom dead center. किसी को doubt है इसमें?
No, sir.
No, sir.
Okay. Now when this crank rotates in this clockwise direction, it will try to push the piston up. And when this crank will come like this, okay, when this crank will become like this, what will be the position of the piston?
Top dead center.
It will be top dead center. That means to complete one stroke, again, very good question of MCQ, if you can see. If it completes one stroke, the crank has rotated how much angle?
180.
180. That means I can write from 0 to 180. If I take the reference from vertical, from 0 to 180, it will be a intake stroke. Now again same. Now the piston position, when the crank has rotated from 0 to 180 degree, the piston is at the top dead center. Now again with the same logic, when it again turns, if I do the cumulative angle calculation, if it turns again from 180 to 360, what kind of stroke you can expect from 180 to 360?
Compression.
It's a compression stroke. So again, you can observe on the second diagram only, when it turns from here to here, the angle will be, or from here to here, it will be 360 degrees. So again, I will write compression. Then again, if it again rotates by 180 degree, that means from 360 to how much? 540? Kitna hoga? 6, 8, 6, 14, yes. 540. It will be power stroke. And when it turns from 540 to I think 720, it will be exhaust stroke. किसी को doubt है इसमें? The angle made by the crank in various strokes. Okay. Now if you have seen the total angle traveled by the crank. Now what can you tell about the rotation of the crank in one cycle? What is the total rotation of crank in one cycle?
2.
2. Again,
2 rotations.
correct, perfect. So here I can say that for one complete cycle, crank makes 2 rotations. Keep this in mind for further use. I will ask you later. That we have already discussed this, that for one complete rotation of SI engine for a 4-stroke, again I repeat, for a 4-stroke cycle, one complete cycle crank makes 2 complete rotations, that is 720 degrees rotation. So I hope this slide is clear to you all.
Yes, sir.